Hello, you're welcome to this lesson. In this video, we are going to solve this question I have on the screen. The question says three identical resistors are connected in star across a three-phase 420 volt supply. If each resistor has a resistance of 50 ohms, calculate A, the voltage across each resistor, B, the current in each resistor, and C, the total power supplied to the load. So let's look at how you're going to solve this question. So the question says we have three identical loads, which means that all the loads are the same. So for that reason, they are all going to have resistance of 50 ohms. For this reason, we can calculate the voltage drop across a single resistor, and then that will be the same as the voltage drop across the other two, same as the current also. Let's look at how you are going to solve it. So from my previous video on three-phase AC circuit, we learned that the line voltage in the circuit will be equal to the square root of 3 multiplying the phase voltage. And the line voltage has been given to us as 420 volts. So we know that already. And the phase voltage will be the voltage across each resistor. And then that is the value that we want to find. So you can make that the subject, which will give us the line voltage divided by the square root of 3. So when we do this, we are going to have 420 volts divided by the square root of 3. So let's simplify this and see what you are going to get. So 420 divided by the square root of 3, that will give us a value of 242.5 volts. So this will be the phase voltage, which is the voltage across each of the resistors. So now let's look at how you can find the current in each of the resistors. You know that voltage is equal to the product of current and then resistance. Okay, so to find the current, you just have to make the current the subject. But in this case, you want to find the current on each resistor. So you can see that the phase voltage should be equal to the phase current times the resistance. Let me write this in small text, and the resistance of the load. Okay, so you're going to have the phase current to be equal to the phase voltage divided by the resistance. We already know the value for the phase voltage, which is 242.5 volts, divided by the resistance, which is 50 ohms for each one of them. So let's simplify this and see. So you're going to have 242.5 volts divided by 50 ohms. So when we do this, you're going to get 4.85, which I write as 4.9 ampere. Okay, so this will be the phase current flowing through each of the resistors. So let's look at how you can calculate for the total power supplied to the load. Power is given by the equation P equals voltage times current. Okay, so to find the power supplied to the load, what you do is that you find the power on each load, and then since there are three loads, you multiply by 3 to find the total power. So you're going to have the power on a single phase to be equal to the phase voltage multiplying the phase current, and this would be equal to 242.5 multiplying the phase current, which is 4.9. So let's punch this on the calculator and see the answer you will get. So 242.5 times 4.9. This will give us a value of 1188.3 watts. Okay, so this will be the power on a single load. So to find the total power, that will be that value multiplied by 3. So I'm going to have 1188.3 multiplied by 3. So 1188.3 times 3. Then this will give us a value of 3,564.9 watts. So this will be the total power on the load. Thank you very much for watching this video. If you find this lesson very useful, please make sure you like the video and also subscribe to the channel.